Hello everyone, my name is Anton Ta and I'm part of Team 5, along with Ryan Kim, Tavia Jones, and David Offing. Today we'll be presenting our project, the Hotel Reservation Database.
In this slide, we have design conceptual.
Hello everyone, my name is Anton Ta. Hello everyone, my name is Anton Ta and I'm part of Team 5, along with Ryan Kim, Tavia Jones, and David Offing. Today we'll be presenting our project, the Hotel Reservation Database. Just a quick intro before we start, and why we decided to go with this idea is because the COVID-19 pandemic happened like less than a year ago. So we figured that with everything reopening, we don't even have to wear masks in school anymore. So many people are looking to travel now. And with that in mind, hotels need an adequate way to manage their systems to handle hundreds of new travelers coming in. Hotel database systems are needed to handle large amounts of data generated, including information about bookings and customers. We think that this information should be stored in an organized and structured manner, allowing information to be processed and fetched easily and quickly, performing tasks such as checking in guests and generating reports.
In this slide, we have design conceptual model. The conceptual model is made to resemble the hotel reservation system itself with 9 different entities represented. The reservation bills service, guests, rooms, employees, and company. Several relationships are modeled, including mandatory one, optional many, mandatory many, and optional one. For example, the relationship between hotel and employee is mandatory many because a hotel should have many employees for it to run smoothly. The bill has the most relationships because it is connected to many classes, including the guest service and reservation. Design supertypes and subtypes. The inclusion of supertypes and subtypes seeks to enhance query performance and simplicity of the database. In a supertype-subtype relationship, there are completeness constraints and disjointness constraints, as well as partial specialization and overlapping rules. This is relevant in the room entity because a hotel can have different types of rooms such as suite, VIP, and regular. Contrarily, the employee subclass uses a disjoint rule because an employee cannot be a manager and housekeeper at once, and has partial dependency because there are many positions an employee can have without being listed as a subclass. Design logical model. The design of our database as a logical model. Model is in third normal form with no transitive or associative dependencies. 8 different entities with unique primary keys. All attributes are dependent on the full key. Entity cluster, reservation booking. To make a reservation, a guest must choose a hotel first. When a reservation is made, a reservation ID is automatically made. And a guest must also their information before making a reservation. When booking a room, a guest must also choose what kind of room they would like, including the number of beds and the price the rooms cost. Unique guest ID and room ID will also be automatically generated. Entity cluster, hotel staff. A hotel will have information such as address, city name, rooms, ratings, and employees. Employees is a separate entity connected to the hotel entity by a foreign key. Each employee has an employee ID, name, email, job description, and phone number. This makes the information about an employee much easier to see. Entity cluster, room service. Room service can also be separated into an entity cluster with the room it is performed in. When a guest orders a room service, a new service ID is generated with the service type and date. The room for which the room service is provided will have the room ID stored. Entity cluster, billing. In order to access billing information, we must first know which guest it is for and the reservation they made. Once the guest information and reservation information is obtained, hotel staff will know how to access the bill. A unique invoice ID will also be generated for each bill. In this slide, we have data dictionary, entities, hotel, reservation, and room. For entity hotel, we have hotel ID, address, city, name, rooms, rating, reservation ID, company ID, and employee ID. For reservation, we have reservation ID, the start date, end date, price, room ID. For the room, we have room ID, beds, price, service ID, and the guest ID. We also included the data type, description, range required, and PK or FK for each entity. In this slide, we have data dictionary, service, guest, and bill. For the service entity, we have service ID, service type, and date. For the entity bill, we have invoice ID, guest ID, reservation ID, room price, service price, late charge, and payment date. For the entity guest, we have the guest ID, name, address, phone number, email, city, and country. We also include data type, description, range, required, PK or FK for each entity. In this slide, we have the physical design. Just to go over the gist of this slide, we have A, denormalization refers to undoing a normalized entity to create more efficient data retrieval and increase the performance of our database. B, the most relevant entity that should access the database is the reservation agent, parentheses, employee class. C, to easily access the different attributes in our hotel database, we would utilize the index file method. And D, a well-designed database must also implement an extensive data recovery policy. In this slide, we have the SQL queries. Now that we have established our database design and we have separated entities into their own groups, we are now able to actually create a database. We made a database in MySQL so that we can write queries to retrieve specific information from it. We must first create separate tables in MySQL to represent each separate entity and to specify the data types that the tables will hold. Our design consists of 8 different entities with varying sizes and data types, which we will have to specify in MySQL. We also establish the primary keys and foreign keys of each table. To actually make queries run, we must insert dummy data into the database so that when we run the queries, the data from the tables will actually show. For our use case, it is only important to show that the queries work the way it is intended to, and therefore it is not important for the dummy data to actually be accurate or representative of the real world. Our last step in demonstrating the functionality of our database to actually write queries to retrieve some information that we would like to see from a good design by demonstrating that the design is capable of filtering on many different criterias and capable of calculation using the functions of MySQL. Database structure. In this slide, we have the database structure, which consists of the table in action. The table consists of bill, company, employee, guests, hotel, reservation, room, and service. The actions consist of browse, structure, search, insert, empty, and drop.
So now that we have established our database design, we had to make a